Let's talk about recursion and the Fibonacci sequence in Mathematica. So remember, the Fibonacci sequence is the sequence that starts 1, 1, 2, 3, 5, 8, 13, and so on. And in general, each number other than the first two is defined as the sum of the two previous numbers. So how can we use functions in Mathematica to produce this sequence? So it's sort of like induction. Recursion is often like induction, where you have to start with one case and then like build up beyond that. So Fibonacci is a special type of recursion in that you actually need two base cases, not just one base case. So in Mathematica, I could write something like this. F bracket 0 is equal to 1. Okay, this is like saying that in the 0th position, we're going to start with 1. Okay, I could have done f of 1 equals 1, would have been just as fine. So then I have f bracket 1 equals 1. And now here's where it gets interesting. So I use a pattern here. So this doesn't mean n. This means anything I plug in, let's call it n. And then colon equals, so that says don't try to compute it now, try to compute it later when I call f bracket 17, for example. And then that is going to be f bracket n minus 1 plus f bracket n minus 2. And this is basically a good definition of the Fibonacci sequence. But if you try to type this into Mathematica and then you try to evaluate, for example, f of 30, you're going to see that it takes maybe 2 seconds. And if you try to do f of 50, then your computer is not going to be able to handle it. And so let me try to tell you why that's the case. So for example, let's talk about what happens if we evaluate f bracket 4. So say I write f bracket 4. I ask Mathematica to evaluate this. Then what does it do? So it says, okay, well, this should be f bracket 3 plus f bracket 2. Okay, so let me write it like this. So I have f bracket 3 and I have f bracket 2. And then I want to add these together, and then that sum is going to be f bracket 4. But it doesn't know what f bracket 3 is. So it uses this definition again. F bracket 3 equals f bracket 2 plus f bracket 1. And f bracket 1 it does know. Okay, so that's 1. And what about f bracket 2? Well, that's going to be f bracket 1 plus f bracket 0. So that's going to be 1 plus 1. And so f bracket 2 is 2. And so you might think, okay, I can just write this equals 2. But that's not how computers work. They don't know to like remember this value here, at least not the way I have it written down. So instead, we're going to have a lot of redundancy. So this, it's going to be f bracket 1 plus f bracket 0. So it has to repeat this part. And if I want to do instead compute f bracket 5, okay, then what would I get? Okay, let me write it over here. So here's f bracket 5. So it's going to be f bracket 4 plus f bracket 3. Okay, and then I have to recompute f bracket 3 for the way it's written, okay, because Mathematica sees f bracket 3, and then what's f bracket 3? Well, it's f bracket 2 plus f bracket 1. So are you getting a sense for why this takes so much time if you try to do something like f bracket 30, or why it takes an unreasonable amount of time if I do f bracket 50? And how many different computations is it? Well, it's something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And in general, I think it's going to be something very close to maybe 1/2 of 2 raised to the 5th power, something like that. So this is the amount of steps that's needed to evaluate the 5th Fibonacci number, the way I've written it here. That number of steps, it's going to take what's called an exponential amount of time to compute. So the complexity of this function that I've written, it has what's known as exponential complexity. So by the time I get to f bracket 50, that relates to like 2 to the 50th number of steps, which is more than what a computer can handle. And so how can I fix this? Well, it's a very simple fix, and it's just kind of an ad hoc solution. Let me show it to you. So get rid of this. Okay, forget that line and replace it with the following line. So it's kind of weird. It's like I have f of n equals f of n. Okay, and then this part stays the same, f of n minus 1 plus f of n minus 2. And so why is this different? Like, what's the special thing about it? Well, the special thing is, notice that here I don't have the colon equals. So this is telling Mathematica to remember this value. So for example, by the time I've computed f bracket 3 here, whatever it is, I guess it's 2 plus 1, I guess it's going to be 3. Then I don't have to go through this whole branching procedure again over here. It's just going to remember that this was equal to 3, so it's not going to compute it more than one time. And this is some procedure that has a special name in computer science, and that special name is memoization. So it's like memorization, but without the R. Hey, and that's a useful trick or a useful procedure for recursive functions. Okay, recursive functions like this Fibonacci sequence.